my name is Jordan, and today we'll be talking all about home electricity and everything that goes into it when you flip the switch. So the first thing I'd like to discuss is how power is measured. When you get your electricity bill, it will typically come with the unit of kilowatt hours. Now what does that mean? Kilowatt is the direct measure of power. Power is voltage times current. Here in America, the average voltage is 110 volts for your outlets, and usually circuit breakers are set up to 15 amps. What that means is that you'd have a maximum wattage on one singular outlet of 1500 watts. Devices that generate a lot of heat, like toasters or ceramic heaters, will use almost the full capacity of wattage. Well, what that means is 1500 watts is 1.5 kilowatts. So if you ran your ceramic heater for 1 hour, you would use 1.5 kilowatt hours of power. Now, that is probably the worst case scenario because most devices around the house don't use close to 15 watts, but combine every device in your house and that is the amount of power that you would be using in kilowatt hours. Now the next question you might ask in that line of thinking is, why do certain devices use more power than others? Now this is because power, as I previously said, is current times voltage, but both voltage and current are related to the resistance. So a device like a toaster has a lot of resistance where it makes the electricity travel through little heating coils that have a lot of resistance. This bumps up the amount of current that's flowing through and thus raises the amount of power needed. So a device, say like an LED light bulb, doesn't really make a lot of resistance in the light bulb, and so the power is way lower. Now that we've talked about how power works, let's talk about how it's functionally used in the house. I'm sure everyone is familiar with the standard outlet, which has 3 separate prongs. The first of these prongs, the more oval-shaped one, is called the earth ground. Now, interestingly enough, that is actually not part of the electric circuit and doesn't get any current sent to it whatsoever. It is solely there to dissipate external electrical forces that might come from stuff like a lightning strike or a short circuit from another device. However, in normal use, the wider of the prongs is the common ground, which is where the current actually travels to when it's operating in its normal circuit. The smaller of the prongs is called the hot wire, or where the current actually comes from. So it comes in the hot and goes out the ground. Now you're probably aware that the power coming in your outlets and throughout your house is AC current, or alternating current. But I just said that the current comes in this one prong and out the other. So that doesn't really seem like it's alternating back and forth. The way alternating current works is by alternating between a positive and negative charge in the electricity. And so that sine wave, as it comes in, is still only traveling in one direction. Fun fact, in America, that's set to 60 hertz, which means that every second it alternates 60 times. And that's actually how any electric clock that's not battery based, such as maybe your microwave, that's how it keeps time, is just with the power coming into it. Now that we've learned about outlets, let's talk a little bit about switches. A simple one-pole switch, where there's only one light switch that controls all the sets of lights in an area, works pretty simply, where when you flip it to on, it connects the wires and makes a complete circuit, and when you connect it to off, it disconnects them, and there's no completed circuit, so there's no power. But more interestingly is what's called a 3-way outlet or a 4-way outlet, which you've probably seen if you've connected multiple light switches to the same light, so that you can control one light from multiple sides of a room. The way that those switches work is by having a fourth wire that connects the two switches, and each side has a lever. So if both levers are in the upward position and connected by one wire, it's a completed circuit and they're on. If both switches are in askew positions, they're disconnected. There's no continuous circuit. And so this wire connecting them is empty and this wire connecting them is empty. So it's off. And then if you put it to the other position, they're connected again. Now that only works if you have up to 2 outlets. Once you get past 2, you need a new 4-way kind of switch, which instead of having a lever like this, has a mechanism that goes from an X to 2 parallel lines. That way, if you have the 2 end switches that I was just referring to, and they're in opposite positions, you can still connect them with that switch by making an X. But if they're in a vertical position or a down position, you can connect them with the parallel lines. And that's how multiple switches will run the same electrical outlets or lights. The last thing I'd like to talk about is some energy conserving tips and tricks. So first thing I'd like to talk about is phantom power usage. What that refers to is when a device is powered off but still using a small amount of power. For example, a TV, when it's powered off, is still drawing a small amount of current. That's how it powers the light that shows that it's off. That's how it can respond at just the press of a button on the remote to turn it on. It needs to be constantly scanning for the remote signal. So that uses a small amount of power. Something like Wi-Fi controlled light bulbs are actually always on because they need to be looking out for Wi-Fi signals shooting out to them, telling them to turn on. What that doesn't refer to is a device that's plugged in to an outlet that's off, or when the device has a physical switch in it. For example, a standard toaster, if it's just plugged into an outlet, doesn't draw any current because there is no ability on the toaster to draw power when the lever is not down. Now don't go running home thinking that you need to unplug every device that possibly uses phantom power, because in all honesty, the average light bulb that's waiting to get a signal is only using 0.1 watts, and the average TV waiting to get your click remote only uses 0.2 watts. So really, you need to run one light bulb for only 6 minutes in order to make up for a whole 24 hours of waiting with your light bulbs just sitting there. So phantom power is a great concern, but not necessarily something that you need to freak out and turn off every device for. The last thing I want to talk about with saving energy is going back to my talk about what uses more power than others. So everyone wants to save energy by turning off the lights or by unplugging unnecessary devices, but you got to think about it. Lights use a relatively small amount of electricity as compared to other appliances. So if you can cut down on the use of heaters or high-powered devices, that'll save way more electricity than shutting off the lights for 2 minutes when you go out of a room and then come back. So I'm not saying that you shouldn't try your hardest to save energy on the small things, but just think about it. If you're going to be using a heater for 2 hours in a day, but then concerned about turning the lights off for 5 minutes, really your impact isn't that great. So just those are some things to consider when trying to conserve energy around the house. And that concludes my talk about electricity. Well, I hope you learned something, and I hope to be back with more videos soon. See you next time. Bye-bye.